Hello everyone, myself Dr. Pramod Kumar Poladi, working as Associate Professor and Associate Dean at School of CS and AI, SR University, Warangal, Telangana, India. In this lecture, I am going to explain you about what are the operators available in Python. Prior to that, first I'll be explaining you about what is an operator and what is an operand and what is an expression, how the expression is going to be evaluated based on the operators involved in the expression. First, I will start with what is an operator. Basically, to perform any operation by the computer, first we have to give certain instructions to the computer. Once we give an instruction to a computer, then the computer starts performing an operation. That instruction, whichever is helping the computer to perform an operation, actually requires certain operators. Basically, operator is a symbol which is to perform certain mathematical or logical operations. Once any symbol is placed either in between two values or prior to a value or among certain values, then some specific operation will be proceeded. Either that specific operation can be, as I said, mathematical or logical operation. The values which actually involves in the operation to be performed by an operator are called as operands. Yes, for example, here is a expression. That expression is 10 plus number. Basically, expression is a mathematical equation type which has certain combinations of values and operators. In this example, 10 plus num. 10 and num both are the operands and plus is the operator. That operand either can be a constant value or a variable. In this example, 10 is the constant value and num is the variable. Means 10 can be always same in the operation and num can be a variable one. Num can vary from time to time, right? In order to perform certain kinds of operations, the Python supports for various kinds of operators. Now we'll list out what are the operators supported by Python. Coming to the first operator set, arithmetic operators. Second one is relational operators. And third one is logical operators. And fourth one is assignment operators. And fifth one is bitwise operators. Sixth one is membership operators. And finally, the seventh one is identity operators. Each set of operators has certain number of symbols. So this classification has been made based on the similarity. If you take arithmetic operators, all arithmetic related operators has been grouped into that class. Similarly, relational, similarly, logical, until identity operators. Yes. Next is arithmetic operators. What is an arithmetic operator? Generally, arithmetic operators are the operators which are to perform basic mathematical operations like plus, that is addition, minus, that is subtraction, and multiplication, division. In addition to these four mathematical operations, even the Python supports for three more arithmetic operators. Those are modulo division, floor division, and exponentiation. So these are the three additional. Altogether, the Python supports for 7 symbols which are to perform arithmetic operators. Now we'll look into each of that symbol and its corresponding operation. Yes, here is a table wherein we can see what are the symbols and what are their corresponding operations and what is the meaning of each and every symbol and an example. Yes, coming to a very first symbol, that is plus, that is unary plus, or that is addition operator. Generally, that addition operator is used to perform addition operation. So once you put an addition operator in between two operands, it carry out the summation operation. Yes, coming to this example here, number 1 is the variable which is holding the value 5, and number 2 is the another variable which is holding value 6. When I add number 1 plus number 2, then both the values will be added, hence the result becomes 11. So in that way, it performs the addition operation. And second one is subtraction operation, where it is also same. If you place it in between two operands, then it performs a subtraction operation. Example, 5 minus 6 is minus 1. Then multiplication, it is similar to a normal mathematical operation, the normal mathematical multiplication operation, where if you place it in between two operands, the first and second operator will be multiplied. Hence, the result will be shown. Now, if you look at 5 into 6, the result becomes 30. Then, next one is division. So, division operation is also same. If you place it in between two operands, the first operand will be divided by the second operand. But here, in case of a division operation, it returns the coefficient. If that coefficient value is the float, even that float result also will be given. 5 by 2 means the result is 2.5. The next one is modulo division operation, that is via percentage symbol. So if I place that percentage symbol in between two operands, it also performs the division operation. But instead of giving the coefficient as a result, now the modulo division operator gives the result as a remainder. See, in this example, number 1 is 13, then number 2 is 5. When I perform 13 modulo division 5, it returns the result as a 3. The 3 is the remainder. Then there is one more operator, that is floor division operator, which is two division symbols, combination of two division symbols. Here, it will give us the result as an integer division. If you look at number 1 is 5 and number 2 is 2. Now I would like to divide 5 with 2 by using a floor division operation. If I just perform the division operation, the result becomes 2.5. But as I am performing the floor division operation, it will neglect the decimal part. Hence, instead of giving a 2.5, just it gives us only 2. So integer part only will be considered. The rest, nothing but the decimal part will be truncated. Right. That is the difference between division operation and floor division operation. Division operation just gives us the coefficient as a result. Then the the floor division operation gives us the result as a integer division. Right. Coming to the last symbol, that is combination of two multiplication symbols, that we call as a exponent operator. This operator is to perform a power operation. See, in this example, number 1 is 3 and number 2 is 4. When I perform number 1 exponent number 2, the number 1 will be multiplied by itself for number 2 times. See, if you take number 1 as 3 and number 2 as 4, 3 will be multiplied by itself for 4 times. That is 3 to the power of 4. Hence, the result becomes 81. So, these all are the 7 operators which comes under arithmetic category. Yes, coming to the next one. Yes, arithmetic operators. Some of the arithmetic operators not only for operations to perform on numbers, even the plus and multiplication operator perform the operations on strings also. Coming to the first example, plus operator can also be used to concatenate two strings on either side of the operator. Doesn't mean that when you place that plus symbol in between two numbers, that performs the addition operation. But the same symbol, if you put in between two strings, that performs the concatenation operation. Concatenation operation doesn't mean that combining two strings together. That too, at the end of the first string, second string will be appended. Here is an example. String 1 is equals to hello. When I placed that hello in between two pairs of two double quotes means that is a string. Then string 2 is India, where I kept that India in pair of double quotes. Of course, in the Python, either I can place collection of characters in between pair of double quotes or single quotes or even in triple quotes. Right. Now, coming to this example, string 1 is hello and string 2 is India. I would like to join them. I would like to concatenate them. For that purpose, I am using plus operator in between. Hence, at the end of the hello, the India will be appended. Then the result becomes hello India. Then second one, that multiplication operator repeats the item on left side. So here is an example. String 1 is India and string 1 into 2 means it is for repetition purpose. Whatever the characters are there in string 1, those will be repeated for 2 times. In string 1, what we have in string 1, we have India as a set of characters. Those has been repeated for twice. Hence, the result became India, India. So, if you have observed clearly, in the first example, I kept the string content in pair of double quotes. In the second example, I kept the characters in a pair of single quotes. There is no difference at all. Both are same, right? Coming to precedence of operators, right? Prior to discuss about the precedence of operators, here I would like to tell you one important point. Generally, when you give an expression to a computer, before the computer is going to evaluate that expression, first it checks with two things: whether the operators involved in an expression are with the same priority or different priority. Once again, I'm repeating, once we give an expression to a computer to evaluate, then the computer checks whether all the operators involved in that expression are with the same priority or with a different priority. If all the operators are with a different priority, then priority rules doesn't mean that precedence rules are applied. If all the operators involved in that expression with the same priority, then the associativity rules will be applied. Now we will discuss about when the precedence rules are going to be applied and when the associativity rules are going to be applied with an examples. Okay. When an expression contains more than one operator, then their precedence determines which operator should be applied first. Higher precedence operator generally evaluated first than the lower precedence operator. If we take arithmetic operators like multiplication, division, plus and minus, basically the multiplication and division are having a highest priority than the plus and minus. There are certain important points to be noted down. Prior we discuss the examples. Parentheses can be used to override the precedence of operators. Of course, set of parentheses also we call as an operator, which is having a highest priority than these operators. So once if you put something in between a pair of parentheses, that will be given a highest priority than the other operators. So the expression within parentheses is evaluated first. That's the reason why I have told you which is having highest priority. For operators with equal precedence, the expression is evaluated from left to right. That we'll discuss in the next example. Right. Here are two examples. The first example is 20 plus 30 into 40. If you look at this example carefully, this example is an expression actually. As I've told you, expression is a combination of operators and operands. Before it is going to be evaluated, first what happens, it will check with the number of operators available in the expression. Now, how many operators we have? We have two operators. One is the addition operator, other one is the multiplication operator. Are they having a same priority? No, they are having a different level of priority, nothing but precedence. In that case, the highest precedent operator will be applied first, which is having highest priority, multiplication. Hence, that will be applied first. Means 30 into 40 will be the first operation. That result becomes 1200. Then later, that 20 will be added to 1200. Final result becomes 1220. So in this example, what I have told you is the highest priority operator will be applied first than the lowest priority operator. That is precedence of operators. Coming to the second one, in the same example, what I'm trying to do is, instead of giving an priority to the multiplication symbol, I'm keeping that 20 plus 30 within a parenthesis. Hence, whichever the sub-expression you keep inside the parenthesis, that will be given a highest priority. So instead of getting a 1220 as a result, now we will be getting a 2000 as a result, because first 20 plus 30 will be the operation. Hence, the result becomes 50. Then that result will be multiplied by 40. Hence, it becomes 2000. So the basic priority of the operators is going to be changed via a parenthesis. Yes, this is all about the precedence of operators. One more example here. Here is an expression where we have 3 operators involved and 4 operands involved. 15.0 and 4.0, 8 and 3.0 are the values. Among the 4 values, 3 are the floating values and 1 is the integer value. Then coming to its solution, of course, as I've told you, when something is placed in between a pair of parentheses, that will be given highest priority. Hence, 8 plus 3.0 will be the operation to be proceeded first. But when you look at the step 1, here the 8 became 8.0. Means when any mixed expression is given to a computer, it checks with the type of the operators involved. The operators with the lower type gets converted to a higher type. The meaning is that in this expression, as I've told you, there are 3 operators with the float data and 1 operand with the integer data. That integer data is the lower data type than the float. Hence, automatically that integer 8 gets converted into a float. Hence, it became 8.0. That's the reason why here I've mentioned 8.0. That will be done implicitly, automatically by the interpreter. We no need to write anything there. Right. In the step 1, first what I am doing, I am performing 8.0 plus 3.0. Hence, it becomes 11.0. In the step, then now at step number 2, we have 2 operators. One is division, other one is addition. Of course, division is having a highest priority. Hence, that will be done first. The result becomes 3.75. Later, that will be added to 11.0. Final result becomes 14.75. Yes, coming to associativity of operators. Yes. If the operators are involving in an expression with a different priority, of course, we will be applying a precedence of operators. But when an expression wherein if you encounter the operators with the same priority, then you cannot apply the precedence rules. Wherein you are supposed to apply the other rule. That other rule we are calling as a associativity rule. Right. This associativity rule in Python determines the order in which operators of the same precedence are evaluated. If multiple operators have the same priority, the associativity decides whether evaluation should proceed from left to right or from right to left. Here are 2 examples. Basically, most of the times the associativity is applied from left to right only. In fewer cases, that associativity is going to be applied from right to left. In the first example, how that is going to be applied from left to right. If you look at this carefully, there is an expression, result equals to 20 minus 5 minus 3. How many operators we have? We have 2 operators, which are minus and minus, that is subtraction and subtraction. It is appeared twice. Whether should I perform 20 minus 5 first or 5 minus 3 first? That is the ambiguity. In such cases, implicitly, internally, by the interpreter, automatically one rule will be applied. That rule is the associativity rule, where the operator which is encountering at left side will be applied first, followed by subsequent. In this example, the first subtraction operator is appearing in between 20 and 5. Hence, the result becomes 20 minus 5 is the 15. Then 15 minus 3 will be the next operation. Then the result becomes 12. Then there is another example here where repetition operator I'm using. When result equals to 2 exponent 3 exponent 2. When I perform that operation, of course, here also exponent operator is used twice in an expression. Should I apply that first exponent first or the second exponent operator first from left to right? Means in such cases, interpreter automatically decides because this operator is having associativity rule from right to left. Hence, the second exponent operator will be applied first, that is 3 to the power 2. Then that result will be 9. Then the 2 to the power of 9. The 2 to the power of 9 result becomes 512. So in majority of the cases, when the expressions are under evaluation with the same priority, left to right associative will be applied. In the fewer cases, right to left associated with rule will be applied. This we no need to remember. Just we write an expression, we hand over that expression to the CPU to perform an operation. So internally, the interpreter will decide whether the left to right or right to left associated with rule to be applied. Right. Then the next set of operators are relational operators. What are relational operators? And when we apply the relational operators? Generally, not only in Python programming language, in any programming language, the relational operators are used to compare two quantities. Here the quantity means an operand. When two values are given to a symbol, that symbol actually compares both the values and decides whether the result is true or false. So basically, the relational operators yields the result either as true or false, means the result is of Boolean type, right? Then here are some examples. Before I explain about the example, first I want to consider certain values with the variables, where number 1 I am considering as 10, number 2 I am considering as 0, number 3 again I am considering as 10. String 1 I am considering as good, and string 2 I am considering as afternoon. So with these, I would like to explain the relational operators. Right. How many relational operators we have? The Python supports for 6 relational operators. Of course, in this chart, I have shown you only 4, but at the bottom, you can find 2 more. The first relational operator is the equals to, the second relational operator is the not equals to, and third relational operator is the greater than, and fourth relational operator is the less than. Even we have 2 more, similar to greater than, less than, greater than or equals to, and less than or equals to. Yes, coming to the examples here. So in the previous slide, I have shown the values which I am going to consider here. Here, I would like to compare number 1 against number 2, whether both of them are same or not, equal or not. Number 1 value is the 10 and number 2 value is the 0 I am considering. So 10 is not same as or not equals to 0. Hence the result becomes false. That is Boolean result. Now one more. String 1 is equals to string 2. String 1 content is good and string 2 content is afternoon. Of course, good is not same as the afternoon. Hence the result becomes false. Then coming to the not equals to symbol here, or not equals to relation operator here. Here I would like to check whether the number 1 content is not equals to number 2 or not. Of course, number 1 content is 10 and number 2 content is 0. They are not equals to. Hence the result became 2. And string 1 is not equals to string 2. Of course, this is also true because string 1 is good and string 2 is afternoon. Both the strings are not same with each other, not equals to with each other. Then next one is number 1 is not equals to number 3. Of course, here it is false because the content which we given to number 1 is 10 and the content which we given to number 3 is also 10. 10 is not equal to 10 is false. Hence the result becomes false. And the third operator is greater than symbol. Here in the greater than symbol, while applying a greater than symbol, I am considering the same values. Number 1 is greater than number 2. Is it true or false? Of course, true. 10 is greater than that of 0. Then string 1 is greater than string 2. True or false? Of course, string 1 is good and string 2 is afternoon. In terms of the string comparison, the string 1 is obviously greater than that of string 2. Hence, the result becomes true. So about this comparison, we will be discussing more when we discuss about the strings topic. Then second one is less than. Of course, number 1 is 10, less than that of number 3. That is also 10. This is false. Then similarly, we can apply the less than or equals to and greater than or equals to. So the relational operators are 6 here. Equals to, not equals to, greater than equals to, less than or equals to. Every relational operator yields the result as either true or false. That is of type Boolean. Right. Next set of operators which are supported by Python is logical operators. Basically, there are 3 logical operators. These 3 logical operators are also to perform a logical operation. the result of all the three logical operators is again either true or false. That is of type Boolean. So generally in C, C++, and Java, the logical operators are the symbols. But coming to Python, these are logical operators are not symbols. These are the words. Those must be written in lowercase. And, A-N-D, O-R, N-O-T, not. These all must be written in the lowercase letters. Yes, coming to examples. And this is basically logical and purpose. And all is basically for logical or purpose. And not is basically for logical, not purpose. Yes. Coming to first example, where number 1 is 10 and number 2 is minus 20. Now I would like to see basically logical expression is a compound relational expression wherein more than one relational operators are involved. Coming to the first example here, number 1 double equals to 10. This is what? It is a relational expression 1. And number 2 is equals to minus 20. This is also a relational expression. In between two relational expressions, I am using a logical AND. So when I apply logical AND operator, prior to that, the relational operation will be done because the relational operators are having a highest priority than the logical operators. Similarly, when I include an arithmetic operator in the relational expression, first priority will be given to a arithmetic operator because until and unless you perform an arithmetic operation, you cannot perform a relational. Similarly, until and unless you complete the relational operation, you cannot perform the logical AND operation. So first, number 1 equals to 10 will be tested against. Of course, that is true. Then number 2 is equals to minus 20. That is also true. True and true becomes true. So logical AND operation result when result is true when both of them are true. If any one of them is false, the result becomes false. Coming to the second example, number 1 is 10. Of course, that is true. But number 2 is not 10. That is minus 20. So this is false. True and false becomes false. When both the operands are true, then only it gives the result as a true. If any one of them is false, obviously the result becomes false. Coming to the logical operation where number 1 is 10 and number 2 is 2. Now I would like to check. Number 1 is greater than or equals to 10. Is it true or false? Of course, 10 is greater than or equals to 10, true. Then number 2 is greater than or equals to 10. Is it true or false? Of course, this is false because number 2 is true. Though this is false, the result becomes true because if any one of the operand result is true, then the result becomes true. In case of a logical OR, anyone can be true to get result as true. Then in the second example, number 1 is less than or equals to 5. This is false. And number 2 is greater than or equals to 10. This is also false. False and false becomes obviously false. And third operator is logical NOT. In case of a logical NOT, see number 1 is equals to 10. And number 2, now I would like to check whether that number 1 is equals to 20 or not. Of course, it is not false. But as I'm applying a NOT, the result becomes true. This is negation kind of thing. Then number 1 equals to 10 means that is true. But I'm applying a NOT operator, no? Hence it becomes false. So these are the three logical operators. Now coming to next operators, that is bitwise. Basically, bitwise operator's purpose is to perform an operation at bit level. Though you give a decimal value, of course, the bitwise operators basically performs an operation on integers only. When you give any decimal integer, first that decimal integer gets converted into a binary. On the binary, at bit level, operations can be proceeded. Hence, we are calling it as a bit level operators. In order to perform bitwise operations at bit level in the Python supports for the below operators. Altogether, it supports for 6 operators. The first is bitwise AND, and second one is bitwise OR, and third one is bitwise NOT, and fourth one is bitwise XOR, and fifth one is bitwise right shift, and sixth one is bitwise left shift. So these are the 6 operators. We'll discuss about each of them with an example. Yes, coming to here, bitwise AND. So bitwise AND is the operator which returns 1 if both the bits are 1. Otherwise, it returns the result as a 0. Coming to this example here, A is 10 and B is 4. Doesn't mean that 10 and 4 are the decimal values. Before we apply the AND operation, that is bitwise AND operation, first the 10 and 4 have to be converted into a binary form. The binary equivalent form for the decimal 10 is the 1010, and the binary equivalent value for decimal 4 is 0110. Now on these binary values, I am performing a operation here, bitwise operation. So first, I am starting from LSB bit position to MSB bit position. That LSB is the least significant bit and MSB is the most significant bit. Generally, we start from LSB and we'll reach towards a MSB bit to complete the operation. First, I'm starting at LSB, that is 0 and 0. The result becomes 0 because false and false is false. True and false is also the false because it is bitwise AND. Then false and true also the false. Then true and false is also the false. Hence the result becomes 0. That 0, if we convert into decimal, that becomes 0. The next one is bitwise OR operators. So the bitwise OR returns 1 if either of them are 1. Doesn't mean that if any one of them are 1, then the result becomes 1. Here are some examples. Same, 10 and 4 I am taking. 10 equivalent binary value is 1010, 4 equivalent to binary value is 0100. I am applying here same process. From LSB bit position to MSB bit position, I am applying the operation. So false and false, of course, false. True and false. As one of them is true, the result becomes true. Here, false or true. As one of them is true, the result becomes true. Here, true or false. As one of them is true, the result becomes true. Right? Hence, the result becomes 1110. Its equivalent decimal is 14. Then one more example here where both of them are true. Then what happens? That we'll also see. So 5 and 3, I'm applying bitwise OR. 1, 2 are true. Result becomes true. False or true, the result becomes true. Then true or false, the result becomes true. Then false or false, the result becomes false. Doesn't mean that if any one of them is true, then only the result becomes true. If both of them are false, the result becomes false. If both of them are true, then the result becomes true. Right? That is how this bitwise OR operator works. Coming to the next example, this is bitwise NOT. So the bitwise NOT operator returns one's complement of the given number. Here I am giving a number as a 10. So on it, the one's complement operation will be applied. One's complement operation means first the decimal value gets converted into a binary. For that, 1 will be added. That is the one's complement operation. After adding 1 to 1010, then it becomes 1011. That is equals to 11. So as it is one's complement, the result becomes negative. That is minus 11. Then the next bitwise operator is the bitwise XOR. It returns 1 if one of the bits is 1 and the other is 0. Else returns false. Right. Coming to this example, where same 10 and 4 I am considering as the operands. Of course, you know very well that 10 equivalent binary is the 1010, 4 equivalent binary is the 011, 0100. On that, I am applying the bitwise exclusive OR operator. See, false and false, of course, 0. True and true, false, the result becomes true. Then false, true, the result becomes true. Then true, false, the result becomes true. This equals to a 14. Coming to another example where the 1 and 1, 0 means what? In case of exclusive OR, exclusively one of the bit must be true to get the result as true. If both of them are true, we will be getting 0 only. But in case of a normal bitwise operator, if both of them are true, the result becomes true. That is the difference between bitwise OR and bitwise exclusive OR, right? Then here is the example. So program which I have executed. I am printing the result of A bitwise and B. Then the result becomes 0. Then I am printing the A bitwise or B result, that is 14. Then I am printing the one's complement of A, that is bitwise not, that is minus 11. Then I am printing the A, that is exclusive OR, bitwise exclusive OR B. Then the result becomes 14. Yes, shift operators. These are the two important operators which we have in Python. These operators are used to shift the bits of a number left or right, thereby either multiplying or dividing the number by 2 respectively done. Coming to this, generally when we shift the bits of a binary number towards a right side, the value of that number gets decreased. Doesn't mean that it is equals to a division operation. When you multiply, when you shift the bits of a binary number towards a left side, then the value of that number gets increased. Doesn't mean that the number is going to be multiplied by 2. Here, either division or multiplication, both can be done with 2 only. Right. Coming to the first bitwise right shift. Here is an example. The example I am considering is A equals to 10. So the equivalent binary value for 10 is 00001010. I would like to shift A right shift 1. Doesn't mean that the binary digits of A will be shifted towards the right side by 1 position. So when I shift the bits by 1 position, this is equals to 5. So simply we can understand that when I divide 10 by 2, the result is 5. One shift equals to dividing the value by 2. If I would like to go with 2 shifts, then that is dividing that value by 2 twice. So here 2 operands. One operand is the value actual one which is going to be divided, and the second operand is the other one that is representing number of times that value is going to be divided by 2. Right. The second example, for example, if I take A equals to 20 and A right shift to 2, then the 20 will be divided by 2 twice. Hence the result becomes 5 again, right? Then here is a second example, that is a negative value. Then bitwise left shift, shifting a bits of the binary value towards the left side obviously leads to a incrementation in its value. Then here is an example. The A decimal value is 5. Its equivalent binary value is 00000101. Then when I say A left shift 1 means the bits in the value A has to be shifted towards left side only once. Then when I shift it towards left side only once, its value becomes 10 because it is equals to multiplying that value by 2 one time. So 5 into 2 becomes 10. Then A left shift to 2 doesn't mean that the same A value has to be multiplied by 2 times. Hence that becomes 5 into 2 into 2. That is 20. Right. Same is applicable even for negative values also. Then this is an example where I am considering A value as decimal 60, B value as decimal 13, and C value as decimal 5. So when I perform, obviously those gets converted into their equivalent binary values. These are the equivalent binary values for 60 and 13. Then A and B, A or B, A exclusive or B, then logical bitwise not, then A left shift, A right shift. These are the corresponding values after evaluating the bitwise expressions. Right. Then next one is assignment operator. The meaning of assignment operator is before we use a variable in the expression, first that variable should be assigned with a particular value. Until and unless you assign a value to a variable, it is not going to hold that value. until and unless it holds a value, it is not going to be involved in an expression. So that is the reason why the important point here is that variable must be assigned with a value. Either that value can be an integer or float or string, or even it can be a boolean, whichever the type of the value we assign, but it must be assigned. So without assignment, we cannot proceed. In order to assign the value to a variable, there are certain operators. Of course, basically there is a single operator, that is assignment operator. In general mathematics, we call as a equals to symbol, right? So this general assignment operator assigns a value to a variable. In this case, number 1 equals to 2 means 2 as a value assigned to a variable called number 2. From now on, whenever I use the number 2 in an expression, that represents value 2. That's the meaning of it. Then number 2 is equal to number 1. Doesn't mean that whichever the value assigned to number 1 will be copied into the number 2. Right? That means both are pointing to the same value now. Then another example, country is a variable. To that I am assigning India as a string. Then when I print country, automatically prints India. In addition to a normal assignment operator, when I use that assignment operator along with the arithmetic operators, it works like a shorthand assignment operators. Shorthand assignment operators. If you look at this example, x plus equals to y, this is same as x equals to x plus y. So instead of writing x equals to x plus y, I can write it in a short form as x plus equals to y. That is shorthand notation. This is applicable for all the arithmetic operators. Here is example. Number 1 equals to 10 and number 2 equals to 2. Now number 1 is equals to number 1 plus number 2. Instead of writing number 1 plus number 2, I am writing here as a number 1 plus equals to number 2 in a short form. Such a way, all the arithmetic operators can be notated in a short way by using this notation. Right, membership operator. So this is one of the important operators among all the operators in Python, where this operator is used to check if a value is a member of the particular sequence or not. If you have a set of values with you, to check whether a particular member is available in that set, is present in that set or not, we can use the membership operator. So here membership operators are of two types. One is in, other one is not in. So in operator basically returns true if the variable or a value is found in a specified sequence. Otherwise, it returns false. Coming to example, I am considering a sequence 1, 2, 3. This is one sequence. So in that sequence, now I would like to check for 2, whether 2 is present in number sequence or not. As the 2 is present in number sequence, it is returning result as 2. Then next example, I would like to check for 1, string 1 in number sequence. I am putting that one inside a pair of single quotes. It is not number 1. It is a string 1. So there is no string 1 present in a number sequence. Hence it is returning for result as a false. Then the next one is not in. It returns true if the variable or the value is not found in the specified sequence. Otherwise, it returns false. Coming to the same example, number sequence is 1, 2, 3. I would like to check whether 10 is not in number sequence or not. Of course, 10 is not present in number sequence. Hence, it returns result as a true. Now, 1 not in number sequence. Of course, this is false because 1 is present in a sequence. Hence, it has given result as a false. So basically, the membership operator is to check whether a particular value is a member of that sequence or not. Then one more operator. This is the final operators in a Python, that is identity operator. Generally, it supports for two. One is, other one is not. Then the purpose of this identity operator is to check whether both of them are identical to each other or not. What is the meaning of whether they are identical to each other or not? Means whether both of them are located on the same part of the memory or not. If two variables that are equal does not imply that they are identical. Right. Coming to this example, x1 value is 5, means x1 as a variable is holding the value 5. y1 is a variable also holding a 5. In a Python, what happens, though you give a different variable names, both will point to a same memory. The values are clearly stored in a locations. When you say x1 equals to 5, x1 will point to a location where 5 is present. When you say y1 equals to x, that y1 equals to 5, even the y1 is also referring to a same memory location. So as x1 and y1 both are referring to a same location where 5 is stored, both are identical. When I ask whether the x1 is identical to y1 or not, it gives the result as true. The next one is a string example. X2 is equal to hello. Hello is a string stored at a particular location. Say its location address is 1000. Now I am assigning same hello to y2. When I assign same hello to y2, it is not going to preserve that in another location, example 2000. It also refer to a same location where the 1000 already having hello. So x2 is referring to 1000 location, y2 is also referring to a 1000 location. As both of them are referring to a same location, both of them are identical to each other. Hence the result is true. Then one more is not. So here I would like to ask the interpreter whether x1 is not identical to y1 or not. Of course, the result becomes false because the x1 is representing location 1000 and y1 is also representing location 1000. As both of them are representing a same location, the result becomes true. Here, both of them are representing the same location, the result becomes false in case of is not. Thank you. Hope you understood the concepts clearly.